Well, hello everyone, welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at this floppy drive. I know everyone groans when they see floppy drive content, but this is the second channel, perfect place for it. What I'm doing with this floppy drive, which is a Franklin Ace 1000 drive, is I need to see if this thing can work and, well, be cleaned up a little bit. It's in pretty rough shape. A friend of mine here in Portland, Tim, does all my disk archiving and scanning of manuals for me. And one thing that Tim doesn't have is an Apple 5¼ inch floppy drive. What these are good for, in combination with the applesauce, which is a disk archiving device that Tim uses, is it's really good at reading Apple II and Commodore drives, or disks that is, because you can flip the disk over because it doesn't, both of those systems don't use the index sensor. And strangely enough, the applesauce really can't ignore the index sensor. So if you're using a PC disk drive for archiving purposes and you flip the disk over, it's not happy with that. So apparently, when you use a drive like this, in combination with a little sensor you wire in and it plugs into the applesauce, then it has the ability to accurately read GCR encoded disks like the Apple II and the Commodore use. So this would be perfect for Tim to use, and yeah, I just need to clean it up and see if it works. Give it a full test, and then I can pass it over to Tim so he can do tons of disk archiving. So for those who aren't familiar, the Franklin Ace 1000 is an Apple II clone, and I've shown those on the channels a few times in the past. The machine is 100% Apple II compatible, and the disk drive subsystem that came with those things is also 100% Apple II compatible. So these disk drives are 100% compatible with the official Apple II or Disk 2 controller from all the Apple II lines. If it has a pin header like this, it will work. Of course, you can't plug this into something like Apple IIc, at least externally, because it doesn't have a pin header like this. So if you find one of these out in the wild, you can be rest assured that it will work on your Apple II, and it just similar styling to an Apple II drive. One thing I like about these is they tried to differentiate the way they look a little bit from the Apple II floppy drives, and they added a little bit of a lip here to the front edge that's not on the Apple drives. The Apple drives are completely flat on the front, and the metal does not overhang like it does on this. So I suppose if you have this on your desk and you spilled some coffee on it, maybe your coffee would just go off the front and wouldn't end up inside the disk drive. Also, the vent slots, which aren't really necessary because it's not like these drives really get that warm. Well, they're on the sides. And on the Apple drives, they actually wrap around to the top. Although, I think on Apple II drives, the vents, which do wrap around the top, are not actually open. I think there's a sticker over them on the inside, which keeps dust from going inside. On this drive, on the other hand, I can see through the slot that the drive mechanism is in there. So those are not covered up. Anyhow, condition-wise, this drive is dirty, and I don't know for sure if it's actually going to work, but I think these mechanisms are quite reliable, so I don't really foresee any issues. Franklin decided to actually put this big piece of heat shrink over the ribbon cable, and I think there's some shielding in there, since there's a little ground strap, which you're supposed to attach for FCC reasons, I'm sure. There's like a label or something taped on the side, plus some Sharpie writing, number 15. There's a little hole in the case. That's almost certainly to adjust the drive speed without taking the cover off. That's a nicety. On the bottom of the drive, there's a lot of filth on here. All the feet are missing, the screws to get into it are there, but there's a hole to allow you to see to the spindle. Excellent. That's really great for user serviceability. If the drive is spinning and you're trying to adjust the speed, you can use the pattern on the spindle in conjunction with the 60 hertz or 50 hertz, depending on where you are, flicker from your lights, and then you can adjust the speed potentiometer on the speed control board there and get that calibrated without the need of any special software. What I can also do is try to spin the drive and, okay, it's moving. It was a little sticky to get moving there. I think this drive's been exposed to a lot of corrosion, and that could mean that the bearings on the various motors and spindles are not going to work super well. But we'll see if we can recover this drive and get it working properly for archiving purposes. Now, someone wrote Carmichael, LRC. I wonder if this is a school district of some kind. Franklin Ace 1000 disk drive, serial number and a part number. Ah, look at that, Carmichael Junior High School, LRC, somewhere Washington. Let's see if I can cut that tape away a little bit more so we can see what it says under there. There it is, Richland, Washington. And I'm realizing this is like a library card slip holder. Maybe library card is the wrong name for it, but if you ever got books from a library back in the day, there was a little card inside the cover of the book, and they would typically stamp the due date when you need to bring the book back every time you checked it out. And that kind of makes me think that maybe this floppy drive was something that was checked out from a library, potentially for students to use at home, Or maybe this was stock keeping information for teachers and it would be for classrooms. And 15, maybe this was drive number 15. Look at the bottom, there it is, property of Richland School District, Richland, Washington. There's the Franklin Ace original serial number sticker, EXC98. Maybe that means it was taken out of service or out of rotation in 1998. That would have been a very long life for something like this floppy drive, wow. Mats 2, someone wrote on that side. Top, Carmichael, I guess another stock keeping number. Pretty dirty. I'll have to do some serious cleaning on this. It would have been really neat to be able to see the original library card or whatever that's called that would have been with this drive. Right, so first step for us diagnosing this drive is we need to look inside. We got to see if this thing even has any potential of working. If we open this up and it's all rusty inside, then that's going to be it for this drive, and I'll have to find a different one to give to Tim. So 2 screws out, and we just slide this cover off. Oh, it looks like, well, it never really would have worked anyways. The ribbon cable wasn't even actually connected. Probably got yanked on at some point, popped it out of that connector. So one thing I like about Franklin drives, by the way, and the controller side, is that they actually have shrouded connectors. And that means, well, this one isn't even keyed, but how about the other end? Is this side keyed? Oh, come on, it's not keyed either? So theoretically, you could have plugged this in the wrong way. If they had just installed a key on there, then you wouldn't have been able to plug it in the wrong way, because we all know when you plug this in the wrong way, it destroys a bunch of the ICs on these boards. It sends 12 volts into things that, well, shouldn't have 12 volts in them. If this drive can be made to work, I'm going to be doing away with this shrouded ribbon cable thing here just for, well, it's super inflexible and stiff right now. So we'll just be able to cut this away because inside here is just some tin foil basically hooked up to this and then some heat shrink on it, and it's all moldy and dirty. Okay, well, looking at the drive, things look a lot better inside than it did on the outside, and that's just because those vents were on the sides. That means junk couldn't really fall into the drive. Pre-test, don't know who makes this drive. Looking at the mechanism, you can see there's a spindle there. I'm gonna guess this is actually a Shugart SA390. So Shugart made PC floppy drives, the SA400, and then they sold a stripped down version for sale to Apple, to Wozniak. It essentially removed the controller because Apple IIs use their own controller, and it also removed things like the index sensor, and they were just single-sided drives. And when I look at the mechanism, I think it's only Shugart that was using that kind of spindle mechanism for moving the heads around, as opposed to, well, if you've looked at any other floppy drives, oh yeah, there it is. Yep, Shugart Associates. So that's excellent because these drives are very robust and really, really well made. Yeah, so it's an SA390, exactly the same mechanism as in Apple II disk drives, exactly the same. So even though this says the Ace 10 on the front, well, there's absolutely no difference, except for, of course, this board, since this is designed by Franklin Computer as opposed to Apple, but I don't think there was anything patented on Apple's design. So I'm sure this is exactly the same as the way the Apple drives do it. So what we need to do with this thing, because everything looks good so far, is take these screws off, lift this controller out of the way so we can take a look at the mechanical operation of everything here. We need to see, disconnect the read-write head. We need to see if everything moves and slides and moves properly. So first we'll just check out this PCB. Everything was fine. So here's that spindle I was talking about, and just see there's a groove, a spiral groove, and as this turns, it moves the head. That's the way Shugart did it on the SA400 and then later the SA390s, these cheaper disk drives they sold to Woz and then I guess Franklin. This seems to move without any issue, and I'm pretty sure there's no lubricant on this shaft, and you really shouldn't add any either, because I think it starts to gum up the bushings that slide along that track, and because there was never any lubricant on there, that's why this thing is not gummed up, because it's the lubricant that usually gets gummed up. So what you could do is probably just try to clean this with a little, isopropyl alcohol, but I'm not sure I even need to do that because this does not seem like it even needs that. Now what's curious is when you turn the spindle this way, so that's all the way to track 0, it doesn't turn any further, so that would be like the head bang. And if we go this way, it gets to a point where it feels like there we go, see it's still turning, even though the heads aren't moving anywhere. But the little thingy that goes into the groove, like see how it's just sort of free floating, as soon as it goes back, it will fall into the groove, there we go. So that's kind of a cool mechanism, pretty smart. I don't know what this thing is made out of the spindle, but these always seem to be in good shape and they don't seem to fail. Now see this blue piece of plastic and this round circle here? That's where the index sensor would go if this were an SA400. What I am not sure about is you would need to have a transmitter and a receiver. So like an IR LED plus a little photo sensor. There's nothing down there for the receiver. So perhaps this structure on the bottom is slightly different. Here's our write protect switch, power LED. Those make their way up to, well, the main board right there. And then this is our speed controller board. And that would be the potentiometer you could adjust for the speed from the outside of the case on this particular disk drive. Speed controller board absolutely looks perfect. There's a ground lug that would be used on the SA400 when plugging this into a PC. Sugart was good and they used gold coated pins. So I don't think there's any kind of contact or connectivity problems with these connectors. And it looks like on the main controller, it's gold coated as well, which is a good little tactic. See these little plastic clips? This actually keeps that connector from falling off. Nice touch. And looking at the bottom, one of the nice things is the belt that's on here is also kind of a fabric belt. It doesn't generally fail. What you can have problems with is it can get stuck on the spindle. Ooh, and the spindle is not turning very easily. It's turning, but it's not particularly smooth. I might need to bust out something like the Dremel just to kind of spin this at high speed just to get that bearing kind of loosened up a little bit. So I was just cleaning the dust off and see one of the issues is, see that label has come off. Let's see, let's just take it off because it's just going to fall off. Now on some of these drives, I've found that the spindle gets a bit of corrosion where the belt was sitting, like there's some kind of chemical process that happens, but this one looks perfect. So I'm just going to clean the surface. I have a bit of Windex on my little cloth here. It's already super clean. And as for the belt, I'm gonna grab it where the Windex is there, so it's kind of wet, and I'll just pull the belt through. I'm not using IPA, just using a little Windex, just a little soapy water. So a little bit of stuff came out off in there, but not too bad. And then the motor itself, that seems fine as well. I think this drive is gonna work, everyone. I think it's going to work. This is not clamped right now, so the spindle, it should be free spinning. Notice it really isn't free spinning. So what I like to use is one of these rubber wheels on a multi-tool. So this is my Jank Life piece of crap. I hate this thing because it has no torque. But let's see if I can use this to spin the spindle and just kind of get that bearing freed up a little bit. Right, well, it's smoother. I'd say it spins a little bit more. I'm gonna keep at that. See, it actually spins a little bit after I spin it. I'd expect when the bearings were new on this, this probably spun freely. If you flicked it with your finger, it would spin for a lot longer than it's doing there. But it doesn't feel crunchy, feels nice and smooth now. So I think that's gonna be good. Let's close the disc clamp. See what that does. That definitely, that definitely slows it down. Let's do this again with the clamp down. Yeah, that didn't really change anything. Now, it's not a huge problem that this seems like, you know, it'll require a lot of torque to spin. And that's because the speed controller is generally pretty powerful. This is a pretty powerful little motor, and it does have a tachometer inside. So this actually has active speed control. So it tries to target the 300 RPM or whatever you set with this potentiometer. And as additional torque is applied to the motor, for instance, the disc is clamped and the disc spinning also adds torque, this thing can compensate. And you can see how substantially big this motor is. It is not a little tiny thing. So I don't think it'll have too much trouble spinning things. Now, I have some bearing oil here. I don't even know what kind of bearing oil this is. I'm just gonna put a drop of it on the top there, on the cap. And when it comes to the bearing that's in the spindle here, that's usually a sealed bearing. So adding oil to it won't really do anything. And the other danger is if you put any of this bearing oil around the spindle, if it drips down onto the disc or onto the clamp, then it can slip, and then that can introduce a whole bunch of issues as well. Now I could try putting some bearing oil down on the bottom side of the spindle motor, but the problem is I don't want to get any on the actual spindle, and it's well, it's easy to put a drip, an errant drip on that. So I'm just going to be careful. In fact, using a syringe is often a good idea to get the oil underneath there just so it doesn't get on there, but I think I'm going to leave that for now until I can run this for a while so we can see if this motor really is working properly or not. This is the shaft for the stepper motor. Theoretically, I could put a little bit of oil there as well, just to try to get some into that bearing. Wipe up the excess. All right, we're nearly ready for testing on the computer. Whoops, that's not what I meant to do. There we go. Belt is on. Considering the filthiness of the outside of this case, inside, this drive looks good. This drive looks really good. The only thing that we have left to do is check to make sure the pad is there on the heads, and it is, and that the read-write head itself looks clean, and it does. Yeah, that looks perfect. I don't even need to clean that. Really nice. Excellent. Absolutely excellent. Right, all that's left to do at this point is grab an Apple II and get this thing hooked up, and let's see if this works. I have a feeling this drive is going to work perfectly. Now, unwrapping this cable, there's a lot of aluminum oxide in here. I think this cable got exposed to a good amount of moisture or water was in here. Okay, there we go. I'm going to keep this little ground strap. That's useful for other purposes. Let's give the cable a clean. Get that aluminum oxide off the cable. Little Windex just does the trick. All right, since we're going to be using or working with a clone floppy drive, I grabbed a clone Apple II Plus. So this clone machine, I had plenty of videos on the main channel about this computer. This machine is, this is a Taiwanese clone. Seasonic power supply, everyone. I don't know if you've seen the videos on this machine, but yep, it's made by Seasonic. So company that still makes power supplies to this day made the power supply in my Apple II clone. I'll link to the video for this machine. I think there were several videos repairing this machine. This one, if I recall, had a pretty difficult to fix fault. I won't spoil the video if you haven't seen it. I think it was basically a design flaw. So I'm not sure if this machine ever worked properly, or if it did, it was for a brief time and then it failed. But either way, it works well now. This thing has all sorts of cards in here. This is a 16K language card. This card here is Brad Bell's open source Videx 80 column card clone. This stuff's all available on GitHub, so you can make these yourself. That way you don't have to buy expensive cards on the internet. You can use these, and this is the auto switcher, so it switches between 40 and 80 columns automatically. This is a normal Apple II disk controller card, so that's not a clone card. This one, on the other hand, is, oh, that's a real card as well. So there are clones of those as well available. I'm just going to use this original Apple II disk controller. So this cable is going to go to my boot drive. And then this is the cable that goes to the other floppy. So we're going to plug this into drive 2. We're going to make sure that that is not plugged in incorrectly. In fact, I'm going to grab a marker and mark the connector for pin 1. I mean, it's kind of obvious because there's the stripe, but I'm just going to put a bunch, and there's actually the arrow right there as well. So I'm just gonna make it kind of obvious, like, hey, pin 1, don't plug it over on that side. Don't misalign the connector. And it's not shrouded, as I talked about, which means if you have that offset one way, or for instance, when you plug this in, if you plug it like that, see how it's not connected correctly, or you rotate it around, or you have it offset like one set of pins like that, that would all be bad. That would all be very bad. So make sure you always double check that you have it in correctly, just like that drive. And I just had a thought, before I even turn this on, I'm gonna unplug this from this drive. So all that's connected is this computer and its original drive. I just wanna make sure this computer is still working. Because let's be honest, stuff breaks all the time, and this has been in my office upstairs under a monitor, and this is the Apple II that I use up there periodically when I want to play Apple II games and stuff like that, which is why I had that smart port card in there. But you know, stuff can easily break just sitting there, especially stuff like this that was already broken and was already subjected to a bunch of repair work by me. All right, here we go. Let's see if this thing works. Okay, there we go. Nice. We're gonna switch this into SCART. No, wait, which one are we doing here? I think we'll do this one. Much sharper, we don't need the color anyways. I think it's gonna play music instruction set demo. Speaker's kind of quiet on this thing. But it boots, it works, and that's excellent. That's what I needed to know. Okay, on this disk is, or should be, a copy of Locksmith. That's the tool I use for testing and diagnosing disk drives. Let's boot this machine up. Ignore the way that looks, that's just the RetroTink. Yes, this is Locksmith 6.1 Revision A. So, First thing I want to do is I'm just going to make sure this disk itself is good, the one I just wrote. I know I just wrote it in my PC, so it's a good disk. It verified it as it wrote it. But what you need to go is to U for utilities and make sure caps lock is on if you have a machine with uppercase, lowercase. And we're going to do 16 sector fast disk verify. And we're going to do this on, yeah, that's not a good start. Input drive A. Okay, so right off the bat, we got some bad sectors, and I'm using not the drive we're working on here. I'm using the drive I was always using with this machine, which I know this drive with the machine works fine. So I have to imagine that these problems here have to do with the way I wrote this disk image using a grease weasel. So if we verify this a second time, should just look exactly the same, slightly different actually. I just made another copy of the disk. Let's see if this one reads properly. A little bit better, but not perfect still. I'm just trying to make sure and validate that I have a good floppy disk before I go testing this drive, because I don't want to condemn this for, say, tracking errors or read errors when the disks themselves aren't working in a known good drive. I'm going to pop in the music instruction set disk we just looked at a second ago. So same drive, I'm using this whatever Alps mechanism drive is here, and notice it reads perfectly. Okay, and now I just put the Locksmith disk back in, the second one I made, and it's reading perfectly. So let's just reboot the machine and make sure that it actually boots up into Locksmith. Yeah, 6.0 revision A. I don't think there's any difference. So we're gonna do utilities again, and we're gonna do fast verify, input drive 1. We'll just do this one more time. Good, okay, this disk is working fine. I found that writing Apple II disks on Grease Weasel works for the most part, but you have to have the right type of floppy drive on the PC side, and some drives are better than others, and it just occasionally writes disks that the Apple II is not super happy about, but the tracking on PC floppy drives is always super, super accurate, unlike these types of drives where, you know, the little spindle thing here could be out of alignment or whatever. But I know for sure that the music instruction disk we have right here, plus this Locksmith disk, is working perfectly now in this drive. So I'm confident that when I get this thing hooked up and we test this out, well, that'll be a good test. And that's unfortunately one of the realities of working with these types of disk drives is you need to have like a working system just to make sure you have working disks to start with. If you're going in with a drive that you have no way to say verify that it's working or not working, you're just suddenly working with a lot of different variables where you might run into issues that, for instance, the disk could be bad or the way you made the disk is bad and there's nothing wrong with the drive. So that's why it's really good just to kind of eliminate all possibilities before you even start to work on one of these drives. And of course, when you don't have extra hardware laying around like I do, well, that can just be a little bit extra difficult. Right, okay, so it's now plugged into the computer. The computer's off though. Let's turn on the computer and see what happens. No smoke or anything, and the computer's booting up into Locksmith. So it's good. We validated that with this drive plugged in to the controller, it's not bricking the controller. All of the signals are shared between these two drives except for the drive select signal. So for instance, if this were doing something on one of the other signals, that could keep this drive from working. But it obviously is working fine. This drive didn't spin or do anything, but it's because it never got selected. Now, right now, the read-write heads are not connected, obviously. This wire is sitting here, so I can't actually do a test on this drive. But what I'd like to do is get this drive spinning. I'd like to get it spinning and just run for a while just to make sure this motor is happy, the belt is happy, you know, all the spindle stuff is happy. In fact, I'll clamp this down, just let it all exercise those parts for a while. So first we're going to exit out of Locksmith and we're going to drop to basic. So currently I have this floppy drive connected to the controller in slot 6 and it's drive 2. And we should be able to issue a couple poke commands just to make this drive spin all the time. It's basically just turning on the drive select and motor on signal from the controller. So I think poke 49419.0 should select drive 2, so that doesn't do anything yet, but that's by design. 49417.0 should hopefully turn the drive on. And it didn't. There we go, that was it. So 49385. And drive 1 is currently spinning. So we need to switch over to drive 2, 387.0 for the second drive. Yep, second drive is spinning now. So the access LED is on, which is good, and it's running. And sounds okay, like it's not making any horrible noises. the motor is spinning, and if I lower the clamp, it doesn't really sound like it changes speed, which is good. That's what it should do. I'm going to try to slow it down with my finger here. Oh yeah, there's lots of torque. So earlier when I was using the rotary tool to spin the spindle, you could just do this as well. Just let it run and just leave it like this for say an hour and let the bearings just sort of exercise, warm up a little bit, and that warmth should help liquefy some of the grease, move it around again, get that sticky stuff out of there. And just so everyone is clear, if you're watching this video for troubleshooting perspective, if we do 49386, 0, now drive 1 is selected. And if we want to go back to the other one, 49387, 0, and that went back to drive 2. I think 49384, 0 should turn off the motor. Yep, motor stopped. And if we do 49385, oops, not 6, if we do 5, 0, it should start it. Yep, there we go, start it back up again. So those are the poke statements if you have the controller in slot 6. It'll change if you put it into one of the other slots, but just a good way just to get your drive spinning, just so you can leave it indefinitely. You don't even have to have a working program or disk or whatever to get the system booted. You can just do it right from basic, get your drive spinning. Now, one thing I can do is I can take this little disc and stick that back on there. That little disc will give us a good indicator if this thing's even running close to the right RPM, and it is. It's the outside rings that we're going to be looking at, and notice how the rings are just moving ever so slightly. Locksmith allows us to actually check the RPM. It'll give us a number, but this is another good way to do it. And while this is just running, I want to talk a little bit about this motor. So this is the stepper motor that actually moves the heads around, and it does it by turning that little grooved record looking thing. Now, notice there's actually a little bit of glue on these screws. Now, if you loosen those screws, you can turn this, and that will adjust the tracking. I highly, highly recommend you do not touch that. If you look around on the internet, lots of folks will talk about the fact that, yeah, I had to align my heads on the disk drive. I think that's BS personally. Maybe that's the case, but I don't quite believe it. And the reason why I say that is I've worked on so many floppy drives on this channel. I mean, lots and lots and lots of them were off camera. Alps drives from 64s, like in 1541s, tons of Apple II disk drives. I have tons of disk drives, and I've never had one that was actually out of alignment. I have messed around with that by loosening those screws, but I don't think it actually ever solved anything. I think I was trying to fix issues that weren't necessarily there. And one of the issues is unless you have a known good drive that's aligned properly, if you're working on your own and you adjust one of these based on like one floppy you have, well, that could have been written on a drive that someone messed with as well, and now your drive is not aligned correctly versus all the other drives. So what I always do is I create my disks on the Grease Weasel on a PC, and I use a drive, a 360K PC disk drive that's got a very highly accurate stepper motor. So I know that the disks it makes are properly aligned, and I'm very confident in using one of these in this drive. And if for some reason this is out of alignment, then theoretically I would be okay using one of these discs to make the alignment on this. But I really don't recommend loosening those screws and trying to make that adjustment. If you get a drive where it looks like someone's already done that, like I've already loosened these screws, then I guess whatever, what does it matter? But generally, if the drive's having issues with read-write, I don't think it's going to be an alignment problem. Now, Apple II drives do bang heads all the time, as do Commodore drives, and theoretically, that shock could maybe get this out of alignment, but I really don't think so. This is now making a pretty annoying sound. I generally find things that cause noise on these drives is this. It's this thing. This has a spring in it. See, if I put my finger there, the noise went away. So any noise you're getting, which can cause reverberations and resonances in the structure, which can potentially cause read errors, usually comes from this. So I may try to stop this. I'm going to hit Control Reset. That stopped it. This actually turns a lot more easily than it was turning, but I think I'm going to add a drop of bearing oil. If I could just find my bearing oil. I'm just going to try to carefully get a drop in there. Okay, like that. Okay, let's go back to this drive. Let's close that. So added one drop on the top and one sort of underneath. And I'm gonna let that run for a while, just see if that gets that oil into there. Right, so while this is doing its thing, one other thing I like to lubricate on this is the little track that this latch rides in. There's a peg that rides on both sides here. I like to get a little bit of lubricant and just get that in there because this is feeling pretty scratchy. So I have a little bit of silicone lubricant. Just gonna put a little bit of that on a cotton bud. Just get that in there. And then when we move this back and forth a little bit, oh yeah, right away, that's so much easier. It was just feeling really gummy. I've been working on some other stuff and it's just been sitting here spinning and there's a disc in there. Occasionally I'll hear just a little bit of a strange noise out of the clamp, and if I touch it, it goes away, so I'm not too concerned about that. It sounds absolutely fine right now, and the disc is just humming away without any issue, which is cool. Spinning the clamp manually, it's about the same amount of spin after I stop as before. But yeah, this drive, I think we're ready for actual testing. So I'm going to turn the power off on the computer. And the analog board for the floppy drive is in. It's just loosely sitting on here. This adjustment, by the way, that is for the differential amplifier for the head amp. I wouldn't adjust that unless you know exactly what you're doing and you can hook up test probes. There should be test points on here with an oscilloscope. Turn the computer on. We do need to boot up Locksmith. All right, here we go. Fast verify. We'll just do disk 1 first. That's the Locksmith disk itself in this drive. Looking good. And once this verify utility loads into memory, you can actually move the Locksmith disk, if this is the only one you have, over to the other drive. But we have another disk in there that we know is good. So UV disk 2. Here we go, moment of truth. Nice. Absolutely freaking nice. Now, the funny thing is, the turntable groove thing for moving the head sounds very different than it does on these drives with regular stepper motors. It sounds almost a little screechy or scratchy as that disc rotates, but I think that's just normal, and there shouldn't be any lubricant on there, like there wasn't on this drive. So we're going to swap to the Locksmith disc, the one we booted off of. Pop this in here. Hit space. There we go. Freaking works. Didn't even really need to do anything to it at all. This would have just worked, to be honest, if I just plugged the cable in. That was the only thing that was unplugged when we opened the lid. I didn't lubricate the tracks. I didn't clean the heads. I didn't do anything. I guess all I did is really spin that spindle motor because the bearings are feeling a little gummed up. But I think if I just plugged this in and just run this with those poke commands, that would have been probably all this drive needed. Now I'm going to put the Locksmith disc back in drive A because we are going to go do the disk speed utility. So S for disk speed, and I'm going to do optimum disk speed. I'm going to do output drive 2, and this will erase the disk. So I'm going to put a blank disk in there. So don't do this on your disk that has software you need. So disk 2, yeah, it tells you, will destroy data. And we're going to do medium, and we'll do 2 samples per line. And this will tell us how the speed looks. Now, optimum speed, okay, so it's a little slow compared to what this program thinks it should be. So let's turn that up. Just need a little flat blade screwdriver, and we will turn the little potentiometer on the back. Where is it? Which side is it on? It's on the right side of the drive. So, okay, counterclockwise slows it down. Now I'm turning it clockwise. Now this is a 10-turn potentiometer, which is good. It means it's not super fine. Some of these potentiometers are the type that's like a 1-turn, and you just barely touch them, and the speed changes dramatically. Now the Apple II is very tolerant of disk speed. I'm turning it up just ever so slowly, by the way. The Apple II is very tolerant of disk speed, so it doesn't have to be perfect by any means. But this is that optimum setting, and we're gonna get it right in the middle there for optimum. Now these speed controllers that are on here, of course, are using a potentiometer. It's not like it's a digital thing with a crystal oscillator, so it's never going to be perfect. Not to mention we have a belt and all that stuff. A direct drive, disk drive is always going to work better. But as I mentioned, the Apple II is very, very tolerant of disk speed. It does not have to be that accurate, and well, where it is here is going to work without issue. We're going to exit out of here. We're going to go back to speed. We'll do optimum again, recommended, drive 2. But we will do a fine adjust. So it's going to be double the resolution, and we'll do 2 samples per scan line again. Of course, if we did 3 samples per scan line, it would probably be a little bit less noisy. In fact, let's just do that just to see what that looks like. So fine adjust, and we're going to do 3 samples per line. So it's going to update more slowly, but it's just going to hopefully filter out a little bit more of the noise. So at the beginning, you saw that it was under the line, it was on the slow side, but now that it's just run for a little while, it's more centered in the middle. I don't think there's any real point to use the fine mode that we're in now. Just This drive with the analog speed controller and the belts and all this stuff is just, you're never going to get that exactly right. But right there, what we're looking at, totally, totally fine. Now I'm just going to try 300 RPM just to show you the difference. We'll do medium adjust again with 2 samples, and let's look what my optimally adjusted drive looks like compared to 300 RPM. So it makes it seem like it's a little bit slow. So I guess we're running a little bit less than 300 RPM at this point. The Apple II can totally tolerate 300 RPM with no problem, but for whatever reason, this program thinks the optimal speed is less than 300 RPM. If anyone watching knows the reason why the optimum speed is less than 300, let me know. But what's left for us to do at this point is switch these drives around so that drive 0 or drive 1 is the main boot drive. I'll get this drive out of here altogether because we want to validate this drive has no trouble actually running Apple II software. You know what? This drive deserves to have its faceplate cleaned since it's such a survivor and it's working so well at this point. You know, the one thing that's interesting is the lever doesn't close all the way. I don't see why. Don't think anything is wrong. Nothing looks out of the ordinary, like the screws are in, the fasteners are in. I'm just gonna loosen these 2 fasteners here. Okay, I think I see what's going on. This isn't going down all the way, so it's not really allowing it to click into place properly. Maybe I need some more lubricant on there because you really have to kind of push it until it clicks like that. Then you push there to release it. Don't think it should be quite that clicky. Right, so I have some silicone grease. So I'm going to apply some of this into the track here on both sides. Didn't really help it, so I don't think it's a lubrication issue. It's interesting, it's not something that I've ever run into. I never had to push that hard to get this to kind of click latch. It's funny because if I push down the clamp and then I close the door all the way, it closes and opens without that clicking. Now I feel like investigating a little bit further just to kind of see what's going on exactly. I have to imagine what's happening here is the plastic has changed size or shrunk slightly over time, because you can see these are tapered screws. So there's no way that this can reposition itself, the front door that is. So I'm just gonna take a look at what's happening here. Everything looks totally fine. This thing moves completely freely without any issues. There's no cracks, nothing's broken. There's lots of lubricant in the track. Yeah, this thing is in perfect shape. Although, I don't know if those should be notched the way they are. That might be the problem. Just from use, it's actually eaten away at those pegs. See that notch there? And that keeps this from actually going down all the way. So it doesn't push the clamp down as much as it should because of those notches. Aha! That's a bit of a design flaw. Yeah, that has to be wear. I can't imagine that was there originally. Those were probably round, and that's just wear. So that's our problem right there. That is our problem. Now, I actually 3D printed some replacements of these levers, or latches, or whatever you want to call these, from tandem drives, and I wonder if those fit on here. They use a brass rod as opposed to these plastic pieces, so they're a little bit more robust. Here's an example of what it looks like. So there's the brass rod that doesn't wear out. Well, it looks like on the sugar flapper, this part is plastic, and I can't transfer that over to this one. Looks like the one from the tandem drive does fit in there, the brass rod. So now I just have to get the little rod. I need to cut a rod length for this so I can attach this little 3D printed part. Because on tandem drives, this is the part that breaks. See, the little clips have broken. So luckily these 3D printed parts exist. But I happen to have like a lifetime supply of the rods, the little pieces that will go in this part. Okay, a little bit of cutting and drilling. There's the little bar that's gonna go through this. So if I'm gonna put this one with a brass rod onto this drive, then we need to replicate the way this is. So this goes like that. All right, there we go, like that. I just sort of have to push it through. I think that should work, because this goes like that. Yes, okay, this is gonna fix this disk drive. Well, it's not gonna be so hard to close, at least. There we go, screws are in. Notice the 2 brass rods, and check it out. Nice. No more clicking. It just works. This is how it should work when you open and close it. So definitely on the SA300 or the Sugar latch that was on here, these pegs are worn away, and it sucks because it's not replaceable. I suppose I could try to drill those out and then replace it with a brass rod, but it doesn't really seem worth it, to be honest, since you know, I have these 3D printed replacements. The one issue, I think, is that the brass rod that rides in this track is thicker than the ones that I have. The ones I have are really designed to replace the TM100 pieces that break. On the original TM100 latches, like this one here, instead of using a brass rod across, it just uses these little pegs, and there's one on each side. And that puts a lot of stress on the latch, which if I can get the camera to focus, you see it just breaks them off. So this one is no good anymore since that piece is gone. But these 3D printed ones do work. Oh, look, here's one of the little latch things, the little pegs, I mean. So that's why it puts stress and just breaks the plastic. But the brass rod, if they haven't broken yet on your tandem drive, is a good solution. And this is obviously from a tandem drive, this latch here, and totally works. And to be honest, today I learned that the Sugar SA400 and SA390 use a latch that is fully compatible with the one from the tandem drives. That's pretty cool. All right, with all that, this drive is now ready to boot the computer. So let's stick in a boot disk. So that's Locksmith. If we turn on the computer, that's what headbang sounds like on these drives. Uh-oh, it's not booting. It's not doing anything. That's on correctly. I mean, the drive was spinning, so we know that's not the problem. Well, I'll be. What happened here? Here's a copy of music instruction set. Well, that's booting, no problem. So it feels like I somehow screwed up this Locksmith disk, maybe. AppleCat users, call the dark cat send, 617-468-DARK. Love it. Let's boot again. Okay, music instruction set. That boots right up. So what happened to my Locksmith disk? Why isn't this reading that? Okay, what changed here? Let's do a fast verify on disk 1. Why are you just working? I'm gonna mess with this while it's running. It's fine. That's so strange. One thing I haven't tested on this is we have not tried writing to a disk. So first we need to check the write protect that works. We'll do 16 sector format, and we're gonna do drive 1. I'm gonna flip this disk over because it's write protected. The notch is not cut out. So let's start here. Frankly, I can't remember how this works. If we, you know, it's funny, it's not telling us that it's write protected, it's just putting asterisks, whatever the plural of asterisk is. So if we do a verify, this should not verify. That's what, like, it's probably formatted on the PC or something like that. Unhappy. So we're gonna try to write to this disk here. So this, oh, this is what I was doing the speed test on. And to do a speed test, you have to be able to write to the disk, I think. So that means I think this disk drive is working. So we're gonna do this, we'll format this disk here. Okay, you get an F as opposed to an asterisk when it's actually writing to the disk. So we'll do a verify. Good, looks good. So what I want to do next is I want to do a fast backup. So we're going to copy the Locksmith disk onto that blank disk. Okay. I don't know why it says write protected. That's weird. But let's write onto this disk, space to retry. Oh, it's trying to write to their drive. I accidentally put drive 2. See, it says next to E12, that's saying it's going to copy onto the second drive, which isn't actually connected. So we'll boot back into Locksmith. Fast backup. Oh, I think we do 1-1. Yes, there we go. That's how we switch to, yeah, okay. 14 tracks. So let's start this, insert original disc, insert copy diskette. So we'll put the blank one in, the one we formatted. Yeah, that looks like it's working properly. Apple II discs hold 140K, so this machine has 64K of RAM, plus of course the program itself is taking up some of the memory. So you basically need 2.5 passes to copy disks. I remember this from back in the day when I had a single floppy drive on my Apple II. Now we put the copy diskette or the destination diskette in. Done. Now if we reset the computer, there we go, we booted up on the Locksmith disk. Utilities, verify, disk 1. And this is the disk we wrote on this drive. And it seems fine. Seems totally fine. So I'm just gonna spend a moment to put this back in the original case, which I have already given a little bit of a clean to. And just to kind of preserve some of the history of this drive, I'm actually gonna leave this in the drive like so, and I don't think that's gonna cause any issues. Plenty of room in there, and I don't think that'll ever go anywhere till I get stuck inside the mechanism. And as for the cable, one thing you can do to keep it from getting pulled out is just tie a little bit of a knot in it. It just makes the cable a bit shorter, but that will also keep it from pulling out in the future. Like so. That just gives this a little bit of extra buffer inside, so in case it gets yanked on, it won't come out of the drive. This case only has 2 screws. The original feet are gone, so I just stuck a couple little pads there, a couple little feet there, so that way if you put this down on top of something, well, it doesn't slide around, and it also shouldn't scratch up anything. Those screw heads won't scratch up what you stick this on top of. Just a little bit of cleaning on the front, and I'm gonna leave this stuff for Tim to clean if he wants to get all the rest of that sticker residue off there. But you know, to be honest, this drive, well, you know, it's seen some stuff, and that's just part of the history. I left the other cards inside. Let's turn this computer on, make sure this still works. There it goes. There's no actual floppy disk in there right now, which is why it hasn't booted anything. So we'll just stick this disk in there. There it is, boots right up instantaneously. Do a quick verify, one more pass. Looks good, looks freaking good. All right, that's it for this video on the Franklin Ace 10 floppy drive with the Sugart SA390 mechanism. This thing looked like it was kind of left for dead, but to be honest, I'm not surprised. It just worked. All I had to do was just exercise those bearings a little bit. And unfortunately, that front lever just had seen so much use without lubrication that those little plastic pegs had worn out. So now it sports a front latch from a Tandem TM100 with the 3D printed replacement part with that brass rod. So this thing should work for pretty much the indefinite future. And I'm sure Tim will be doing tons of archiving of Commodore and Apple II discs with this. And because it's an SA390 mechanism, he should have no trouble attaching the little sync pulse thing or whatever the mod is for the applesauce that it needs. Because I'm sure that was designed to be used with the Apple II Disc 2 drives, which is an SA390 mechanism. So that's perfect. This will 100% work for him. Not to mention, you can adjust the drive speed from the outside. And if Tim wants, he can stick that sticker back on the spindle to see the speed under LED lights. And yeah, that was it. So a very casual, chill second channel video working up this disk drive or cleaning up this disk drive. If you enjoyed it, I'd appreciate a thumbs up. I'll try to remember to put links down below to things like Locksmith and the 3D printed part that I replaced the latch with and stuff like that. But if I don't, just put a comment and I'll try to add those. If you liked this, thumbs up. If you didn't, you know what to do. Huge thanks to my supporters. Names up beside the screen. And yeah, that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.